Hi guys, a very good morning. This is Dr. Sajja Suneel from Data Science Department, Institute of Aeronautical Engineering. Today I am here to discuss you about IoT physical devices and endpoint. In this particular topic, I am going to revise you what exactly the interfaces are, such as UART, which is a serial communication. In this synchronous and asynchronous serial communication was there, which is UART stands in synchronous, whereas SPI and I2C went to asynchronous serialization of data transfers. Now we are going to see them in detail. Along with that, how a Python programming is going to be done. All these things are going to be discussed in this today's class, which is a continuation for the previous revision part 1, which is IoT physical devices and endpoints revision part 2 this was. And have a look guys, we'll start with discussing about the things which we discussed so far, and have a look what are the things which are existed in UART. What UART was? It was a simple asynchronous serial communication protocol which is used for short range data transmission. That is what UART was. It was a simple asynchronous serial communication protocol which is used for short range data transmission. Got it guys? This is what UART was. And what was the basic concept which lies in this serial communication? It was a method of transmitting data one bit at a time over a communication channel. This is how the things are going to work by using data transmission. By data is going to send sequentially bit by bit. Synchronization, which must be agree on a common data rate. Start and stop bits. This is how the serial communication is going to be happen by using UART parity bit. This is option which is used for error checking purposes. And have a look what are the types of serial communication: synchronous and asynchronous, which I told you previously. Asynchronous, there will be no clock signal which is used. Only data is going to be transmitted in irregular intervals. The best example was UART. And coming to synchronous, here we are using a clock signal for data transmission. The best examples were synchronous was SPI and I2C. What are the advantages of serial communication in IoT? Cost effective, simple implementation, long distance transmission, and low power consumption. These are the advantages which we are going to get in serial communication in IoT guys. And coming to the disadvantages, and what are the common serial protocols which are existed? UART, SPI, I2C. The best example was temperature sensor for this UART interface. Why? Because this is the temperature sensor which is going to send data temperature to a microcontroller, and that controller is going to process the data and transfers to a cloud platform via Wi-Fi. This is about UART. And coming to the UART protocol structure, which is a universal, UART stands for universal asynchronous receiver or transmitter. Universal asynchronous receiver or transmitter, which is a serial communication protocol which transmits the data one bit at a time. This is the frame which consists of the following elements. Always logic is 0 and the data bits are 5, 6, 7, 8, and the parity bit is optional for error checking, and the stop bit is used for logic. Start bit is 0, stop bit is 1, data bits are 5, 6, 7, 8, and parity bit which is optional for used for error checking. Can be odd, even, none, mark, or space. What you can say, you can use in any way. This was the protocol structure. And the data transfer. Data transfer will be done by based on synchronization, start bit, data bits, parity bit, stop bit. In synchronization, transmits and receiver must agree on the baud rate. Start bit sends a start bit signal the beginning of the time. Data bit, which transfers at least a significant bit. Parity bit, it is transmitted to check the errors. And stop bit, which transmits 1 or 2 bit stops to indicate the end of the data frame. This is how the things are. Ideal state, which is 1 to the next position. and how the flow control is. Flow is essential to prevent the data when the certain things are happening. In this hardware flow and software flow. Hardware flow uses two additional lines, RTS and CTS, request to send and clear to send. These are the two things which are happening in hardware flow. And coming to software flow, there are two special characters, X on, X off, which is used for signaling flow control. And X off is used for pausing the transmission, and X on is used for resume the transmission, guys. And this is how the things are going to be happen in UART frame. See, start bit, word bit, parity bit which is optional, and stop bit. 4 bits of information which is transferred. I already told you in a clear way. This is how the image look like. Got it? And now we will go for serial communication. What are the advantages and disadvantages of UART? The advantages of UART: simplicity. UART is relatively implemented, low cost will be there, flexibility will be there, it is widely supported, long distance communication will be there. These all are the advantages over UART. And coming to disadvantages, there will be a low data rate and suspectable noise ratio will be there, and also it is inefficient for using of bandwidth. These are the disadvantages over UART, guys. And now we'll have a look what this SPI communication was. In SPI communication, asynchronous serial communication protocol, which is used for short distance communication with a high speed data transfer. And what was the master slave architecture which is existed here? Here the master slave configuration, which is having one device as a master and another device acts as a slaves. Got it? Master, which initiates data transfer to generate the clock signal and controls the chip selected line. Slave, which responds to the master commands and provide you the data when you requested by master. So you are a slave, so you are acting for master. And how clocking is done in SPI? In synchronous protocol, which is a meaning with clock signal to synchronize the data transfer between masters and slave by using SCLK, which is a clock signal which is generated by the master rising from the falling edge, where the data is typically sampled on either the rising or falling edge of the clock signal, which depends on device configuration, guys. And coming to the next one, SPI protocol, where the data transfer will be done in full flexed, where we are having master out, slave in, and master in, slave out. This was the data process which involves CSK line and SLK line. And data is transferred in a serial way. Most significant bit is sent to descend the things. This is how master and slave mechanism is going to be in factors. These are the key points which are specified in SPI. And now we will see the advantages of SPI over UART. The advantages are high data rate, full duplex communication, and simplicity. These are the advantages over UART, and also efficient use of bandwidth. These are the advantages over UART. And now the disadvantages: shorter communication distance, master slave architecture, and more complex wiring, susceptible to noise. These are the disadvantages over SPI over UART, guys. In summary, I can say one thing, guys, along with this advantages and disadvantages over UART, SPI is the preferable choice for applications which requires high-speed data transfer between master and few slaves within a short distance, guys. So this UART is only suitable for low data applications and also longer distances, and which requires more flexible communication topologies. This is the summary which I can say you by comparing with UART and SPI. Now we'll go for I2C. What I2C was? I2C protocol, which is addressing. Each I2C device has a unique 7-bit addressing, which allows multiple devices to share some information through the bus. And what are the information can be done? The address can be in form of format and scheme. The address, which includes 7-bit device address and read or write bit. Addressing scheme, where it is followed by read or write and also SDI low line. And coming to the data transfer, I2C is a half duplex, where the data can be transferred by using only one direction at a time. And also start condition, which initiates by pulling SDA. Address phase, where 7-bit address code read and write. Data transfer, where master and slave transmits the data. Stop condition, which terminates the communication by releasing the SDA line while SEL is high. Key points which has to be noted. ITC is suitable for multiple low-speed devices on a shared bus. Multi-master capability provides flexibility in system design. These are the things. Addressing schemes which enables the communication. These are the key points. And what is I2C communication versus advantages and disadvantages? Advantages I2C over UART. Disadvantages of I2C over UART. First, I will let you know. Here, I2C advantages are it is supporting multiple devices. Here we require only few voice. It has built-in addresses and it is also using resistors for simpler writing. The disadvantages are low data transfer, more complex protocol which is suitable to noise due to shared bus. Suspectable noise will be there automatically. And coming to SPI, how this particular I2C is having advantages. Advantages compared to SPI bus which supports multiple devices on single bus, and also it requires only fewer voices, 2 instead of 4, and here simpler filing and addressing system. These are the advantages on SPI. I2C advantages. And coming to disadvantages over SPI was low data transfer, more complex protocol, susceptible to noise rates. These are the things which are existed. And now I will show you a comparison by considering multiple factors such as data transfer, clocking, data rate, number of wires, topology, addressing, complexity, use cases. See here how the data transfer will be done in UART, SPI and I2C. Data transfer will be in serial. In SPI also it is serial. In I2C also it is serial. Coming to clocking, UART was asynchronous, whereas SPI and I2C are synchronous. And coming to data rate, it was very low. Coming to SPI and I2C, it is medium to high and it is low to medium. And coming to number of bytes, only 2, TX, RX. Here, 3 to 4, MOSI, MISI and SCLK, CS. And coming to ITC, only 2, HDA and SCL, which we discussed in the previous slides. Addressing, which is not required here and also not required in SPI, only required in I2C. Topology, it is a point to point, and coming to SPI, master slave, and coming to ITC, multi-master. And coming to complexity, it was very low, and coming to SPI, it was medium, coming to ITC, it was medium. What are the use cases? In the use cases, low speed communication debugging, and coming to SPI, high speed data transfer peripheral control, and coming to I2C, sensor networks which uses low speed peripherals. These are the comparison about UART, SPI and I2C. What are the installation considerations which has to be taken care while placing these IoT physical devices, which includes environmental conditions and security? The first one is device mounting and placement. Mounting and placements are the critical aspects in IoT installation, which requires to the impact, which shows impact on device performance, data accuracy, and also the system reliability. And what are the factors which have to be considered? The factors such as device type and function, what sensors are existed, temperature sensor for heat resources, and which optimize the data collection, which, and coming to actuators, which should be located with effective control, gateways, which should be centralizedly located for optimized network. And coming to the next, environmental condition, either it is avoided for extreme temperature and humidity, we need to consider the resistance if necessary, dust and dust, electromagnetic interfaces. These are the environmental constraints. And coming to physical constraints, whether a comfortable space was there or not, whether the surface type was good or not, and coming to weight and load capacity was good or not, whatever the weight which is going to be holded by that holder or not, those are the things which we need to take care. Acoustics, which is visibility, integration, either after mounting in a particular place, the visibility was proper or not. Specifically, we will compare these things in security systems. Integration, either is there any blind devices are simply in the environment or not. Accessibility, maintenance and user interaction will plays a major role in accessibility, guys. And coming to the mountain options, wall mounting will be there, ceiling mountain will be there. Wall mountain, which is suitable for indoor environments. Ceiling mountain, which is ideal for sensors or devices which requires unobstructed view. That is what ceiling mounting was. Pole mountain, which is used for outdoor applications or elevated positions. And surface mounting, which is used on flat surfaces like table, shelves, like etc. Enclosure mounting, which protects the device for harsh environment, placements to consideration, sensor placement, optimize the sensor placement for the accurate data collection, which need to avoid abstractions and interfaces. And also, you guys need to consider orientation and the field of view. These are the placement consideration factors. And coming to the next placement consideration factor was accotator placement. In this accotator placement, you need to ensure a proper alignment and the clearance of accotator movement was presented or not in this accotator placement. And also, you need to minimize mechanical stress over the accotator, and you need to consider the safety and accessibility, guys. And what are the gateway placements which need to be considered at the time of installation? And we need to maximize the network coverage, and we need to avoid interferences, and we need to ensure a good power supply availability is there. So by considering these factors, you can optimize the device performance and also extend the device lifespan. And also, overall, I can say one thing: you are going to enhance the efficiency of your IoT system by considering this mounting and placement considerations in detail. And coming to the second factor, which is power supply options for installation consideration. What are the things which has to be considered at the time of power supply? The first one is you need to select an appropriate power supply, which is crucial for successful operational longevity of IoT devices. What are the different kinds of power supplies? Battery power supply, and which is used for primary batteries, secondary batteries, and considerations. Coming to battery power supplies, primary batteries which are non-rechargeable, ideal for short term, which is disposal applications like lithium, right? Lithium coin cell alkaline. These are the primary batteries which are used. Coming to secondary batteries, which are using rechargeable, which is suitable for long term, where we are using lithium ion. Lithium coin cell was primary battery, which is non-chargeable. Lithium ion, if we use, means it is chargeable, and which includes nickel metal hydride also in secondary batteries. Whenever you need to consider how much battery life is capable, how much charging that the device was giving, how much environmental considerations are good, and how much safety was there. These are the things which we need to consider at the time of battery power. What are the different kinds of power supplies which are existent? Line power, AC power, DC power, and consideration. AC power was the thing which is directly connected with to the main powers, that is AC power. And coming to DC power, which is often used in industrial settings for a specific device called 24 volts DC. And what are the considerations? We need to check power availability, voltage regulation, safety standards, and power surges. These are the considerations in power, line power. And coming to energy harvesting, which plays a major role. Why? Because solar power, thermal energy, kinetic energy considerations. These are the energy harvesting mechanisms. Coming to solar power, we are conveying sunlight into energy. We are coming to thermal, we are converting heat into electrical energy. Coming to kinetic, we are converting motion into electricity. Considerations: energy output, which were environmental conditions, storage capacity, and efficiency. Solar, thermal, kinetic. Got it, guys? These are the energy things. And coming to the factors which affects on power supply choices are: first, device power consumption. How much power is consumed by the physical device? That we need to take care. And coming to operational environment, how the operations, temperature, how the operation, humidity, physical considerations, all things should be taken care. Battery life, how much battery life was existed to that particular device, whether the battery was good or not, is there any change requirements are required or not. These are the things which you need to consider. Safety, which ensures the compliances with relevant safety standards and regulations. Cost, which balance the initial cost of power supply with long-term expenses. Reliability, we need to choose a power supply with a proven track record with suitable performance characteristics. These are the factors which we need to consider. And coming to the third one, environmental factors in installation considerations. These are the factors which are need to be considered at the time of installation for improving the impact of performance, reliability, and lifespan of our IoT devices. The first key environmental factors are temperature. Extreme temperature, which is affecting device components, battery life, and sensor accuracy. We need to consider temperature ranges where the device will stand. And coming to humidity, high humidity can cause corrosion, condensation, and electrical failures, where we are utilizing with the things. And coming to dust and particulars, where containments can clog sensors, vents, and movement parts. So enclosures has to be kept with a proper filtration. Regularly, we need to clean these particular IoT physical devices. And also electromagnetic interface. These are the interfaces which can disrupt wireless communications and device options, where we are shielding the devices with shielding cables. And also we need to locate these devices away from potential EMI sources, which are potential electromagnetic interfaces, and vibration and shock. Due to vibration and shock also, we need to verify the physical impacts which can create a damage to the components which are installed, and use shock absorbing materials or enclosures whenever you are installing. And you need to secure the device properly. These are the things which we need to take care in those aspects. And coming to altitude, high power altitudes which are affecting the device performance due to low air pressure, which are considering the altitude ratings for components. And also mitigation strategies such as enclosures, material selection, sealing, ventilation, shielding, and regular maintenance. These are the mitigation strategies. In mitigation strategies, enclosures. For protecting the devices from harsh environment, we need enclosures. Material selection. We need to choose a proper material for getting vibration or shock. And we need to seal these devices properly so that moisturizer, dust containments are going to be avoided. Ventilation. We need to ensure a proper airflow has to be there through the in and out of the device. Why? Because so that heat dispensation will be very easy. Coming to shielding, which protects the proper airflow, which protects the electromagnetic interfaces. We require these shield. And regular maintenance, cleaning and inspect devices periodically with a short span of time. And what are the security and challenges which has to be privacy considered at the time of IoT installation? And while security considerations are the paramount concerns in IoT deployment, where we are protecting sensitive data and maintaining the integrity, safeguarding the privacy. And in security consideration, device authentication, we need to ensure authorized users are going through the network or not. Data encryption, where protected data is transferred between the devices. Security, we need to verify the integrity of the device software before execution. Firmware updates. In this firmware updates, we need to implement secure firmware update mechanism. Access control. You need to restrict access devices data based on the user rules and permission. Physical security. You need to protect devices security from tampering and unauthorized access. Network security. We need to implement firewalls, intrusion detection systems, and secure network protocols. These are the security considerations which has to be taken care. And coming to privacy consideration, data minimization was the first thing, which is collection only the necessary data, which is minimalization. And coming to data anonymization, where remove personally identifiable information. And consent management, which obtain explicit user consent of data collection and usage. Data retention, where clear data retention politics, privacy was needed. Incorporate privacy consideration from the beginning of the development. Transparency, we need to be transparent about data collection, usage, and sharing practices. These are the privacy concerns which are to be taken care. And about Raspberry, we need to concise a particular overview on this Raspberry. Why? Because we need to know about this Raspberry. Why? Because its role was as small as single board computer. The best example was credit card sized computer that can be utilized in various projects. We need to highlight GPIO pins. These are the key points. Why? Because Raspberry Pi kit looks like a small credit card, but it can be used in various IoT projects, guys. So we can call this Raspberry Pi as single board computer, where the role is so small, but it will do high performance things. It will solve complex problems. Why we need to highlight these GPIO pins which are existed in this particular device? Why? Because we have some pins which are connected in Raspberry physical board. These pins are going to act as an interface to the Raspberry Pi and physical world devices such as sensors, motors, which are connected with our physical devices, guys. That's why we need to tell these things. And coming to the next one, we need to know about what Python was. Whenever we are talking about Raspberry, we need to know about this particular Python. Python is a versatile programming language which makes very easy to control the Raspberry Pi. So we require an IDE which should be installed in it, and by using this Python programming language, we are configuring the things. Visualize elements. How we are going to visualize? Image of Raspberry Pi. A clear image is going to be shown to you for a better understanding along with the diagram. Have a look, guys. What Raspberry Pi was? Raspberry Pi is a credit card sized low cost computer. It was initially developed by Teach Computer Science in schools, for teaching computer science in schools, but has gained an immense popularity for its versatility. And key features. What are the key features of Raspberry Pi? Compact size, low cost, versatility. It looks very small, like a credit card or debit card which is in your hand. It is low cost for hobbyists, students, educators. Versatility, and can be used a wide range of projects from home automation. GPIO pins, which provides physical connection to interact with the physical devices of the outside world. And operating system, which supports various operating systems, including Raspberry Pi. How this is going to function? We require connectors to a monitor, keyboard, and mouse, where we require multiple applications and software. The best examples for this Raspberry was home automation and robotics, media center, and retro gaming, educational tools, IoT projects. Have a look. Applications: home automation, robotics, media center, retro gaming, educational tools, and IoT project. These are the things which are there in this particular IoT Raspberry Pi. And this was the Raspberry Pi board which is shown to you on screen. Raspberry Pi. These are GPIO pins. GPIO pins. And this is Ethernet. And these are USBs. These are USB slots. And this is power supply, C cable. And these two are micro HDMI ports which are given. And this was the most powerful processor. And this was the choice of RAM, which depends on your requirement at the time of project which you are implementing. These are the things which are shown to you, guys. And have a look what GPIO pins are. These are the versatile pins which are used in Raspberry Pi to configure either inputs or outputs, which acts as an interface between Raspberry Pi and the physical world. And these are used to control the devices like LEDs, motors, reading data from sensors. What RPI GPIO library was? This was a Python library which is specifically designed for controlling the GPIO pins which are there in Raspberry Pi. Simplifies GPIO interactions and also providing you particular setuping functions, reading and writing values also. What are GPIO basics? The basic setup is going to be like this. We need to import the specific library. Whenever you are setting the number of mode like this, you need to set GPIO set mode, GPIO BCM. Whenever you are broadcasting SCOC channels, this has to be done by using the Raspberry Pi board. Import RPV as GPIO. And these are also the things which are recommended to you. For setting mode, this was the thing which has to be done. And for defining a pin, this has to be done. LED pin 18. For switching on the specific thing, GPIO LED pin, GPIO out. Turn on the LED, this was the thing. Turning off the LED, this was the thing. Like this, we need to do the things. Got it, guys? And you please remember this. You need to always refer a Raspberry Pi documentation for a specific pin layout and numbering of your own module which is prepared by you at the time of implementation, guys. And have a look how the things are in this particular setting up. What was the purpose? We need to send some signal out, guys. What was the function? GPIO setup pin, GPIO in. This was the example which is shown to you for your better understanding. Here I have imported GPIOs as GPIO and a pin is highlighted as 18 and I have set up a lead pin as GPIO out. So this is how you need to set up output pin. This is for controlling LEDs. I am turning on the LED with a blinking by using 1 second. Automatically, this was the thing. Demonstrating blinking of LED with a time slip. This is how the program has to be designed. Have a look. Import time while true. Then GPIO out should be high. Time slip 1. GPIO output LED pin. GPIO low. Time slip 1. For every second, for every 1 second, LED blinks. LED is going to be blink automatically. This is how the pulse width modulation was. Once have a look towards the pulse width modulation. The main purpose of this modulation was you need to control average power delivered by the load rapidly. And what are the applications? Controlling LED brightness, motor speed and other analog. And this was a example which is shown to you guys. And this is motor control, which we discussed in our previous classes also. The basic principle was it is shown to the direction control, and H bridge will be there, which is used for controlling the direction of the motor, and PWM will be there, which is controlling the speed of motor drivers, current limitation and heat limitation. These are the considerations which have to be taken care. And this is reading our input. How to set up inputs, receive signals, and this is in function. This is the example for reading input, only input case, and for reading output we have seen. These are the basic buttons which has to be pressed. Once have a look for basic reading how the things are. For basic reading, these are the buttons pressed, and debouncing, these are the button bounce delay, debounce delay. We are implementing a delay to avoid false readings due to debouncing. That is what button debounce was. And coming to pull up and pull down resistors. What was the purpose of pulling up or pulling down the resistors? We need to provide a default state for an input pin when there is no external component is connected, guys. These are the two functions where the input is high when nothing is connected and where the input is low when nothing is connected. Both factors are considered. GPIO PUD up, GPIO PUD down, which is pull up, pull down. Got it? This was the example which has to be written in Python. And how sensor interfacing will be by using analog sensors, using ADC and DAC, analog to digital, digital to analog, temperature, light, humidity sensors. And analog sensors are using only ADC, which is analog to digital converter, which converts analog signals into digital. Coming to digital sensor, which is connected to GPIO pins to read the digital values. ITC and SPI, which communicates with sensors by using these protocols. It is more complex for the sensors. Code examples. This was the example for interfacing with external gadgets. How the sensors was. Devices which are going to respond with physical stimulations. What are the types of sensors? Temperature sensor, humidity sensor, light sensor, motion sensor, ultrasonic sensor, gas sensors. What are the applications? Weather stations, environmental monitoring, security systems are the best examples for these sensors. And now actuators, the best definition was devices which converts electrical energy into mechanical energy to create some particular movement. The best example was motors, relays, LEDs, buzzers, solenoids. The best examples are robotics, home automation and industrial control. And coming to communication protocols, as I told you, there are only 3 communication protocols, ITC and SPI and UART. These two are asynchronous and this is synchronous. Serial communication protocol with short distances and low rates. And here serial communication protocol where is high speed compared to I2C, and it requires 3 to 4 voice, MOSI, MISO, SCK. And here UART requires only TX and DX. These are the things in IoT physical devices and endpoint guides. We will meet in the next class with IoT cloud offerings. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.